We're going to be graphing a quadratic function in factored form. I'm going to review with you the three different forms of a quadratic equation. The first one is in standard form. We've already learned how to graph that one. The blue one here is in factored form, which we're going to learn next. And then the last one in green is vertex form. I just want to review with you how you could convert a factored form equation into standard form. And then you could follow the same process if you want to. So here's a function in factored form. And if you have a binomial times a binomial, you could FOIL this out. So you take first, which is x squared, outside, 7x, inside, negative 3x, and last, negative 3 times negative 7 is negative 21. So your function now has been converted to standard form. Now we have learned the method of graphing this equation in standard form. So if you forget how to graph a function in factored form, just refer back to how you do it in standard form and you'll be fine. All right. So here's an example. We have g of x in factored form. And we want to find the x-intercepts, the y-intercepts, the vertex, and then graph it. So I'm giving you some helpful hints on here, some shortcuts. So step one, we want to find the x-intercepts. Where does it cross the x-axis? So we're going to go ahead and use the zero product property. So we're going to set the function equal to 0. And then we're going to use the zero product property. We're going to set each factor equal to 0 and solve for x. We're going to solve by undoing. So we're going to add 4 to both sides. We're going to add 1 to both sides. So these are the zeros of the function. As ordered pairs, they are 4, 0 and 1, 0. All right, part B. We want to find the y-intercept. Where does it cross the y-axis? So the helpful hint here is we're going to replace the x with 0 and solve for y. So here is our function. I'm just going to replace that function notation with the letter y, and then x minus 4, x minus 1. So now we're going to replace x with 0. So we say y equals 0 minus 4, 0 minus 1. Well, those zeros are going to cancel out. So we have negative 4 times negative 1. We multiply those two numbers together. Negative 4 times negative 1 is positive 4. So as an ordered pair on the y-axis, it's going to go over 0, up 4. So what I'm going to do is just take a moment here and graph the x-intercepts and the y-intercept. So the y-intercept, here's your y-axis. They want my smartboard here for a minute. We'll give it a minute here to come back. All right, I think it's back now. Okay. Y-axis here is 0, 4. X-axis, or horizontal axis, the two ordered pairs. Up here were 4, 0 and 1, 0. So 4, 0 and 1, 0. Okay, so we have 3 points so far. All right, now what we're going to do is we're going to find the vertex. Where is that maximum or minimum point? So the helpful hint is the x value of the vertex is the midpoint of the x-intercepts. So remember, our x-intercepts were at 4 and 1. So what is the midpoint? If you remember midpoint is the halfway point. So you would add these two up, 4 plus 1, and divide it by 2. You're averaging them. Take in the middle. So 5 over 2, which is 2.5. So that vertex x is at 2.5. Now to find the y, you're going to plug x into the function to find y. So our function was this, y equals x minus 4, x minus 1. All right, we're going to go ahead and substitute this 2.5 into for x to find y. So y equals 2.5 minus 4, 2.5 minus 1. All right, now we simplify it. 2.5 minus 4 is negative 1.5. And then 2.5 minus 1 is 1.5. Now we multiply those two numbers together. and we get negative 2.25. So the vertex then is at x, comma, y. So our x was the midpoint of the x-intercepts, and the y was negative 2.25. All right, we can go ahead and graph that point. So we're over 2.5 on the x, and then down negative 2.25. So about there. 2.5, negative 2.25. All right. We head back up to the original problem. Notice that this leading coefficient right here is a positive number. That's going to tell us that the graph is going to open up. So we should see that when we see these 4 ordered pairs here. Here is our vertex. We know it's going to have to open up. It's going to go through that x-intercept there. It's going to go through the x-intercept and then through that y-intercept. So this is our parabola. I am going to take it one step further and go ahead and graph the axis of symmetry, the line of symmetry. That always runs through the x value. So the axis of symmetry is the x equals 2.5. So that's how you can graph a quadratic equation in factored form.